Everyone, welcome to part 2 of the series of videos that I am making on passage planning or voyage planning. In the previous video, I discussed the sources of information that can be used to obtain all the information required to plan the passage. And in this video, I'll be talking more about the planning process. So that was the appraisal process, and this video is on the planning process. I have given the link to my previous video in the description section below, along with other useful videos that you may watch in the topic of chart work and coastal passage planning. All right, so let's get started with the planning process. So in the planning process, basic principles of planning that you have to remember is that a voyage can have three distinct phases. One is the ocean passage, the second one is the coastal passage, and the third one is the pilotage. So ocean passage refers to the vast oceans, the sea passage, where you have most of the times where you have a sufficient sea room for alterations and sufficient depth of water. And the coastal passages refers to the part of the passage where you may have to coast along or sail along a landmass before you reach into the pilotage passage. And the pilotage refers to the port waters, the port waters where the expertise is normally held by a pilot, and that area is the most critical part of your passage because there you have a lot of ships coming in. There is a danger of collision. The depth of water may also be much lesser as compared to the ocean passages. You have land masses and other navigational features around. So those are the three distinct phases of voyages. So voyage planning can then be broken into three parts. One is the preparation, execution and monitoring, and archiving and documentation. Now in the preparation stage, we talked about the appraisal process in the last video, like I said before. And today we'll talk about the planning process. So the points to consider in the planning process is that especially in the ocean passages section, you have to consider the distance between the ports. And when we consider distance between the ports, you have to think about how much oil you need, how much bunkers you require, how much fresh water may be consumed, and how much stores we require. So when we say stores, we are talking about maybe food, maintenance equipments, spare parts, paints, everything that may be required. You also have to consider whether you'll be using a great circle course or a drumline course. I have made separate videos on great circle and drumline setting. Please watch my playlist on celestial navigation and coastal navigation, and you'll have a good idea about it. So I will not go into the depths of great circle and drumline in this video, otherwise it will become unnecessarily long. You also have to think about the meteorological factors such as the winds that you may be facing, any possibility of tropical revolving storms or TRS, whether you will be facing any ice passage or ice accretion at sea or ice accretion on board ships, currents, tidal streams, etc. Whether you would have to seek a port of refuge or whether any port of refuge will be experienced during the passage. For example, during the passage, if you have a broken rudder or a broken steering gear, or if you have a tropical revolving storm that is going to affect your passage, is there any port of refuge where you may seek shelter, or is there an island behind which you may go and seek shelter? So some of these factors have to be considered. Then political requirements, of course, whether that place, the next port is safe for you to go into, whether there are any political disturbances, whether the country is at war or any nearby countries are at war, whether any military exercises are going on, whether any submarines, navigational or navy related exercises are going on, which may threaten the safety of the ship. Then the load lines have to be considered. So sometimes the load line of your port of departure and the port of arrival may be different. So you have to ensure that if you sail out on a deeper draft or a deeper load line, you would have to maybe compensate with the consumption of the stores or ballasting, deballasting, but finally adjust your load line to such that in the next port of arrival, you should be at the appropriate load line. So if you have sailed out on a summer load line and probably you are going into a tropical load line, so you have to consider all that accordingly. The other points that you have to consider is the distance of coastlines and dangers. So if any part of the passage involves you coasting along a landmass, then you have to make sure that you keep a sufficient distance from it because along the coast you will have shallower depths of water, you will have more dangers to navigation, you may have wrecks, or sunk ships or similar dangers, or you may have rocks, islands, so you may have to keep a sufficient distance off, and yet at the same time you have to ensure that you are sailing along the shortest route possible. You cannot take a longer route, because then your company and your ship owners will frown upon it. The possibility to conduct parallel indexing. I'll show you the examples of parallel indexing and what it is. So parallel indexing also refers to keeping a parallel distance of coastlines or dangers to navigation. We'll talk about wheel over points, at what point of the passage or what point of during your ship's track you alter your course to the next course, and what point you start putting the wheel over to ensure that your vessel turns in a sufficient time and sufficient turning radius to join the next course or the next track at the most economical way, without wasting too much fuel or coasting time. We'll talk about stream allowances, tidal stream allowances, and whether they support or whether they go against the vessel's passage. The tidal window, we talks about draft and under keel clearance restrictions. So you have to ensure that your ship always has sufficient depth of water for your ship to transit. So accordingly, you have to calculate the tides based on the draft of your ship, and then ensure that you have sufficient depth of water under the ship, which is called the under keel clearance, to ensure ship is always safely navigating in all waters, whether it's pilotage waters or whether it's coastal or ocean passage. Then you have to think about the routing requirements, which are the shortest passages, whether any passages, and what kind of weather you will experience, currents and other factors that come into play. The reporting requirements to the vessel traffic services or VTS, and I'll cover this more in detail in my next video, but I'll briefly touch on this probably in this video. So we have the reporting requirements to VTS, port authorities, sometimes even well, these are the only reporting authorities. So pilotage, contacting the pilotage, port authorities, harbor master, VTS. During a narrow channel, you may have to contact several VTSs, especially if you have been transiting in Malacca Strait. You know that in Malacca Strait you have several reporting points, so you have a couple of different VTSs that you have to report to. And then you have to think about pilotage requirements. Now most of these places you need a pilot, and you have to consult a pilot because the pilot is the local expert, but there are ports in the world where sometimes the master takes in the ship, so you have to make that consideration, the choice and the decision whether you would require a pilot to take you inside the berth, or whether the master is going to do that. And then of course the positioning availability, whether the ship is going to use the GPS way of position plotting, satellite systems such as GPS or celestial navigation, or taking bearings and ranges of coastal landmarks, whether you have sufficient depth of water or areas available. If tomorrow if you go into the pilotage waters and you realize the berth is not available, do you have enough available space for dropping the anchor, or are you going to drift around? Similar factors like that. And of course, we have talked about the port of refuge already, so I will not repeat it again. Some of the other points to consider is your navigable limits or margins of safety, whether you have sufficient margins of safety to coast along or make alterations or turn the ship around when required, or alter your ship's course to prevent collisions. Any landmark identification, so prominent landmarks need to be marked and also made and brought to the notice of the officers to ensure that your ship, when they are passing the landmarks, they may make a note of it. They may also use it for position plotting. They may also use it for parallel indexing. The no-go areas have to be plotted strictly. These are the areas where the vessel cannot go into in any case, and if there is any threat of the vessel going into these areas, then the master should be called, so the officers should be notified about it. The point of no return. The point of no return is the point after which you cannot turn back. This is normally the point from which you would then go on to proceed into the pilotage, and you would receive the pilot, and the pilot will take you into the waters. Otherwise, you have the contingency anchorage, so the point of no return. If beyond this you cannot return, but before the point of no return, you can always turn your ship back, especially if there is any kind of delay or the pilot is not available or the berth is not free. Then you can go and seek a contingency anchorage. That means a backup plan, a plan B, where you may drop the anchor and wait for the pilot to become free or the berth to free up, and that will be safe for your ship rather than you drifting along, and that will have the possibility of you drifting into the passage of another ship which may be entering or exiting the port. Then the positioning system, the positioning checking methods and the cross-checking methods have to be made sure that you verify them. So you cannot rely on one way of position fixing. You have to have backup position fixing plans available to ensure that you are very sure about the position of your ship. Now, when you are into ocean passages, when there is sufficient sea room available, normally positions are plotted in every hour. But as you start coasting or you are into piloted waters, you engage in more frequent position fixing. So you have to make sure that you have sufficient systems available. You cannot only rely on the GPS. You have to use the landmarks, bearing and ranges of the landmarks, or you may also engage in celestial navigation if required, and ensure that all the positions are showing the ship is at the same position. Pilotage requirements have been considered. Communications, so we talk about channels to be communicated on. What are the piloted channels? What are the communication? What are the VTS channels? What are the channels that you should be monitoring the traffic on? So there are, of course, all this information is available on the ALRS books or eligibility list of radio signal books, and you should be making a note of that in the passage plan as well. The draft restrictions and state of tides have to be made a note of as well, because like I said before, you have to ensure that your ship is always safe, there is sufficient depth of water below it, and your ship never touches bottom. Although I don't want to go into it, but there are some ports where a ship may touch bottom, and that may be safe for the ship to do so because they have sandy bottoms. But most of the times you cannot allow your ship to touch the bottom, and you have to ensure that there is always sufficient depth of water available below it. Manning requirements, of course, you must have sufficient number of personnel available on the ship, officers and crew, to ensure your ship is always safe. And this becomes very important because during open seas and ocean passages, you may not require a steering helmsman or an additional lookout, but especially when you start transiting coastal passages or you start going into the pilotage waters, then you have to make sure that you have a steering helmsman, a separate lookout, an officer on watch, and sufficient crew to maneuver the vessel and help in the maneuvering of the vessel into the berth as well. And then the berthing arrangements, of course, have to be very suitable for the ship. When we talk about berthing arrangements, we have to ensure that the berths have sufficient depth of water for the ship to be always afloat during loading and discharging. There are means to secure the vessel. It is safe for the vessel to be in it, or if there are any nearby storms or tropical revolving storms, the ship is in a sheltered berth, and there are other factors that we have to consider as well. During the planning process, your commitment has to be made to the paper charts or to the computer. In some ships, sometimes you have to do both. You have to have the backup paper charts ready. Some ships you only use the egg disk. If you have a backup egg disk, then that's fantastic. But depends on your company, depends on the culture of the ship and what system your master has or your company has on your ship. But if you are involved in any kind of paper charts as well as egg disk, you have to make sure that you have the passages laid out, the similar passages laid out in both the systems, the paper charts as well as the computer systems, and ensure that it is neat, unambiguous, there are no doubts, it's clearly clear. All the officers should make themselves familiar with the passage plan before the voyage proceeds, before the voyage rather begins, to ensure that there are no doubts in anybody's mind, and if there are, then such discussions should be done by the bridge team and briefed by the master as well. In the planning process, make sure your charts are in order. You have the latest edition of charts on board, or the charts which are there on board have been corrected to the latest notices to mariners as well as navigational warnings. The navigable limits and no-go areas should be plotted clearly for everyone to see. The coastal and the pilotage areas should be examined to see where the ship cannot go. Some authorities recommend cross-hatching of no-go areas so that it is clearly visible to all the officers. If, like I said before, if there are any dangers of the ship ever going into the no-go areas, before that the officers must be instructed to call the master to ensure this never happens. Navigable limits should be considered based on the dimension of the ship, the accuracy of the navigation systems, the tidal streams, and the maneuvering characteristics of the vessel. In terms of the choosing the charts, now I am of course showing you an example of the Australian chart index, but what I'm trying to show you here is whether it's Australia, whether it's any other area, you should be able to select the proper charts. So like as discussed in my previous video, charts have there are several charts available for each area and different scales of charts available for each area, and you must always try to use the largest scale of chart available to you for each area. Now sometimes when you're in ocean passages you may have to use small scale charts, but you must consult the proper chart catalog, whether it's the Australian chart catalog or the British Admiralty chart catalog, or whether it's a separate chart catalog. You must always ensure to use the largest chart scale available, because that will outline the essential features of any dangers to navigation, depths of water, and coastal features, landmarks will be clearly outlined. So go into the proper catalog, go into the proper charts, and select charts based on the area. So sometimes you may have to go into a bigger chart, a small scale chart, and then select the large scale chart from it. So as you can see here, you have various boundaries of charts outlined here. You know, depending on which chart or which area you will be transiting, you know that you have to go into that particular area, and then the information about the subsequent chart or the next chart or the chart covering the particular area is provided. So you can go deeper into this information and select the proper charts available. Alright, so like this is again an example that I'm showing you here, that the further deeper you go into a particular area, this you can see is the Tasmanian island. So if you go into the Tasmanian island, depending on whether you are transiting the east coast or the west coast or the north or the south part of it, you can go deeper into it and then select the appropriate charts accordingly. All right, but at all the time you must ensure that you are selecting the largest scale charts available for that area. As you can see here, I am showing you the scale of charts, the chart number, and the areas that it covers. So this is just an example for a particular area here, but anywhere you go into the world, this is the pretty much the system for it to make sure that you get the proper chart available. Now, then you also have the notices to mariners available as well. So make sure that you use the notices to mariners to correct your charts and publications. They should be corrected up to date. Sometimes I hear people going and joining ships where the charts have not been corrected, and that's not a good practice. But in case you do experience charts not being corrected up to date, you can always go and consult the annual notices to mariners or the cumulative notices to mariners, which provide corrections up to the last 2 years, and you can find out up to which correction your chart has been corrected and then correct the charts accordingly. I know it's a bit time consuming, but you have to do this. You have to make sure your charts are always up to date, corrected up to date. If you are sailing and you are going to be signing off very soon, make sure that you update and correct all the charts and publications, because it's unsafe to sail with charts that or applications that are not up to date, because you may run into a danger to navigation, which is not safe for the ship safety. All right, these are of course you have electronic charts and you have corrections available on CD-ROMs or USBs, and you all you have to do is just pretty much plug it in and run the software and it corrects the charts. But I'm talking about the paper charts here, which are a bit of require a bit of manpower, and it's a bit tedious process. You have to correct each of these corrections individually, and you have to do it yourself. Of course, if you are using on relying completely on electronic charts, it's much easier. System is much easier. It's more easy to and quicker to do so. All right, coastlines are drawn on small scale charts first and then maybe transferred on large scale charts as required. Now, if you have done any kind of great circle sailing, you would know that in great circle courses, you draw the courses on the great circle charts, and then for every 5 degrees of longitude, you note down the waypoint and then transfer those waypoints onto Mercator charts and draw the courses. Otherwise, if you are only using Mercator charts or Rumline courses, then you will be drawing the courses initially on a small scale chart, because that gives you the whole picture between the two ports. So most of the time, these small scale charts, they show you both the ports in one chart, so you get a brief idea about it. But those small scale charts do not show you all the essential navigable features or dangers to navigation. So you draw a rough course on a small scale chart and then slowly start transferring it to larger scale charts, where you have a better idea about the navigational features or the dangers to navigation, and you can make sure that your ship does not pass over any of such dangers to navigation, or is not passing any close to any dangers on navigation. You always have sufficient depths of water below your ship. Courses are drawn always from berth to berth, and course change points are called waypoints and are numbered chronologically. I'll show you an example of waypoints, what they are and how it is numbered. The waypoints are recorded on either the bridge notebook or the spreadsheet, as I'll show you as attached in the notes. Some ships have their own format. and the symbol for waypoint is normally a diamond. All right, if you are using a separate system, I'm not sure about it, but most of the times we use the diamond shape here. A list of standard signals are used in passage planning are included in the supplement section in the chart catalog in the NP5011, which is chart symbols. Now, coastlines are drawn as unbroken line on small scale charts first, and then large scale as required. True direction are shown clearly by the track with an arrow. So we show the direction in which the coastline is proceeding, as well as the course is written in numbers, and it is always written in true direction. It's always true course. Transfer of tracks from one chart to another must be done carefully by range and bearing from a known object. Sometimes if it is not available, you may use a GPS position, but we normally use a known position and then transfer the course line when we are doing so from one chart going into the another chart. Verify the latitude and longitude of each waypoint, and don't forget about the chart data. Draw on the navigable limits as a dashed line, only showing navigable limits where it is necessary. So you draw the navigable limits as a dashed line to show where it is necessary. And I'll show you a few examples of, I think I have a few examples. I'll show you what they look like. The change of the chart is shown clearly on the chart, giving the new chart number, and also it should be recorded in the spreadsheet of the passage plan as an alert or a caution. You may also mention it on the course just before the chart is required to be changed. You may mention it there as well by making an arrow and writing that the next chart is so and so. Do not forget to mention the GPS datum on the chart and the spreadsheet as well. Do not take any unnecessary risks in terms of clearing distances. Always consider the consequences of engine failure or navigational error. Now, clearing distances, and for drawing clearing distances, you must consider the following points. The draft of the ship in relation to the water depth. So make clearing distance, make sure that the ship is always at a safe distance from any dangers to navigation. All right, so to do so, you must always consider the draft of your ship in relation to the available depth of water. You must consider the likely weather conditions, the direction and rate of tides and currents, traffic density of other ships and flow of traffic, and age and reliability of survey, and hence chart information. So when we talk about survey, we are talking about the survey based on which the charts have been constructed. You should not take any kind of risk when drawing clearing distances. You should always keep your ship at a safe distance. Remember, safety of ship is foremost, and after that only we talk about any kind of delays or longer distances. If you keep your ship safe, that's the most important bit in planning the passage. Also keep in mind the desired under keel clearance to ensure that your ship always has sufficient depth of water under the keel and the availability of safe water. For example, if you have the contour lines of that shows draft, your draft is up to 3 to 6 meters contour, then you must pass outside about by 10 meters. Your clearing distance should be about 10 meters. If the contours are 6 to 10 meters, then you must pass 20 meters, and if they are more than 10 meters, depends on the UKC, pass clear of that as well. Remember to allow any kind of maneuvering space if the ship must alter course for traffic as well. We were talking about waypoints before, and I thought I'll show you the waypoint as well. So you can see the waypoints have been shown in the form of diamond shapes. Each waypoint is shown in the diamond. A waypoint is the position on the chart where a planned change of course occurs, and the waypoints are numbered and form the framework or reference grid of the passage plan. So normally you start with waypoint number 1, and then you proceed on to call it waypoint 2, 3, 4, and so on. Or you may have a different waypoint numbering system depending on how you have fed the waypoints into the GPS. So I'm not here to tell you how to number your waypoints, but basically they go in a chronological order. Most of the times they do in a chronological order, but sometimes it may also depend on how you have fed these waypoints into the GPS. But make sure your waypoints are numbered, and they are numbered can be easily seen, so that the officers who have not been part of the passage plan can also easily identify it and find out information about it from the GPS or any other related equipment. A caution, alert, or warning is a position on the chart where some planned change of status or event should occur. Again, referenced back to the waypoints, and they are meant to inform the navigator of a change or alert that are due to take place. For example, if you have a wheel over point, or you may have a point of no return or a contingency anchorage, all these can be written as cautions or alerts or warnings You may use the dialog box, or if you want to use the clearing ranges, clearing bearings, cross track limits, parallel indexing, all these may be shown in the way that I've shown you here on your screen. And the whole idea behind this is that whenever you have an important information on the chart, you must draw it in such a way or mark it in such a way that it draws the attention of the officer on watch. And you have to always remember that you may have been part of planning this passage, of writing this passage, constructing it, but other officers may not have been so actively part of it. So you have to consider them that this is the first time they are seeing the passage plan. So you have to draw their attention to any relevant points, any cautions, any alerts, or any relevant warnings as well. And this is the one that I was talking about. So this is an example of a ship's of a ship's track laid down as courses. You can see the waypoints are numbered chronologically. You have the waypoint number 23, and then you have waypoint number 24 after it. What you see here is the call master position, and the standby engine position is marked on the chart. You also have the call the pilot position marked on the chart with the channel number given to you. So the channel number is channel 12. What you also have are dialog boxes where you have the distance from the waypoints and the distance as you have departed the waypoints, and the distance to the next waypoint as well. So these are the waypoint numbers, of course, and they are provided in serial order as well. So this 23 is then 23.1, 23.2. These are information regarding your passage from waypoint 23 to waypoint 24. So because after you leave waypoint 23, you have important information available in the form of 23.1 and 23.2, and the important information is first you have to call the master and provide the standby engine position, and 23.2 is the information referring to call the pilot, and channel is given as well. All right, make sure your chart numbers and chart notations and identification are unambiguous. There are no doubts about it. These are the distances to the waypoint and from the waypoint. So location measurements help to reconstruct the chart. Course alterations and wheel over points. This coincides with the planned track. However, in confined waters, it can be essential that a ship maintains the planned track, so allowance must be made for wheel over positions. A useful rule of thumb is to allow 1.5 times ship's length for the wheel over distance, but it can also vary depending on the ship's maneuvering characteristics and engines and how responsive your ship is to helm movements. It is always better to define the wheel over as a line rather than simply a point on the track. So I'll show you an example here. So you can see the example here. The wheel over point is shown normally as well as a parallel index. So what you see on the left side is a wheel over point shown normally through a dotted line or a dashed line, and you can see from that point over you have to alter your course from 030 to 070. So the point where the dashed line intersects the firm line is the one that you start making the alteration to the next course, and by the time your ship reaches the next waypoint, your ship will be ready to join the next course of 070 from the original course of 030. The wheel over distance is marked there as well. What you see on the right side is another technique of showing the wheel over point, but here the technique used is a technique of parallel indexing. So you can see that the intention of the officer here is to make sure that your ship during the alteration of the course from 262 to 222 is always keeping a safe distance from a landmark. Maybe that's a landmark, or maybe it's a wreck or a danger, which you see as a dark black line, and then a minimum distance of 1.8 miles is kept from the danger. A parallel line is drawn from that danger to your ship's track, and the wheel over mark is always and again shown as this time as a firm line but as a straight line, and that is the point from which you start altering the ship's course, and at the same time keeping always a safe distance from the danger to navigation. The maneuvering diagram is made use of as well to determine the wheel over points. It also enables the navigator to decide in advance the amount of rudder to apply. So of course the maneuvering diagram is available on the wheelhouse. If it is not, it is available in the maneuvering booklet. So make sure you put a copy up on the wheelhouse and use this maneuvering diagram to get an idea of how responsive your ship is, and because that will also help you to decide in how advanced should you start applying the ship's rudder to make a particular alteration of course. All right, again here you can see the information related to wheel over points and turning of a vessel has been provided, and you can use this information to for example, here you can see measuring a 30-degree turn for 20-degree of wheel has been shown, and officers may use this information to plan the wheel over points on the passage. In terms of radar navigation technique and parallel indexing, I'll show you a few extracts and pictures. It allows continuous monitoring of ship, defines the distance of track, so always helps you to keep a distance of a danger to navigation, making sure you always keep a safe distance. And similar monitoring is also available with electronic navigation aids such as a GPS that you can mark. So you can see here on the chart is shown on the left hand side. So on the chart, this is what a parallel indexing would look like. Basically, you keep a distance, a minimum distance, a clearing distance of a danger to navigation, and it is drawn parallel to your ship's course, and you have to always ensure that you keep this minimum distance. And even if you have to make an alteration to avoid any kind of collision, you have to ensure that you make this distance, maintain this distance. If you are not able to maintain this distance, then you must call the master immediately on the ship's bridge. On the right side, what you see is a parallel indexing technique used on the radar. And you can see here again the index line is set at 1 nautical mile. That is the distance that you have to keep at a minimum from a danger to navigation, and that helps you to keep a monitoring of the information electronically, because you may be busy with alteration of courses, or there may be traffic in those areas. You don't have the time to keep plotting the ship's position on the paper chart and measure the distance. At that time, it's very useful to monitor the parallel indexing on the radar screen, because it immediately gives you an idea. It takes some time, but it gives you an idea in a quicker time and tells you how far you are away from the danger to navigation. In any case, if you are getting closer to the danger, you have to make sure that you call the master before you get into a position where you cannot maintain the minimum distance. You can see again here I've shown you extracts of how a passage plan may look like. This is in a very busy coastal area. You can see parallel indexing techniques have been used throughout, and the distances have been used to measure the on the radar as well. Low-lying area not suitable for parallel indexing references, and if available, change to a reference ahead. So you can see throughout the passage parallel indexing techniques have been used, and minimum safe distances have been kept of dangers to navigation. That could be islands or shallower depths of water, and you have to use this system. Then we have abort points and contingencies. So when approaching constrained waters, the ship may come to a position beyond which it will not be possible to do other than to proceed, termed as point of no return. So after point of no return, you cannot turn your ship back. You should have by then either proceeded with the pilot and gone into the berth, or you may have been taking the ship yourself inside. Contingency is before the abort point. That is the time where you can turn the ship around and drop anchor in case your berth is not available or the pilot is not available. But the passage plan must take into account the point of no return and the fact that thereafter the ship is committed to proceed all the way to the berth. A position must be drawn on the chart showing the last point at which the passage can be aborted and the ship not be committed to entry. Having passed the abort point, the plan should include contingencies for if the ship may have to take emergency action. The contingency plan can include an alternative route or a safe anchorage or a waiting area where it is safe for the ship to just drift around, or emergency berth to wait for its original berth to get cleared up. This is an example of a passage plan spreadsheet. You can see here that the waypoint numbers have so let's start from the very beginning. The ship's name is there, the port of departure and the port of arrival is mentioned there as well. The voyage number is written, so I'm starting from the top, of course. The departure date and the departure time is written. Then we have the date and time of departure. You have the waypoints numbers written as events. You have the waypoint reference written. So waypoint reference refers to any landmark which may be available for you to make a cross check before you alter the course or to plot the position of the ship. You have the latitude and longitude of each of the waypoints written, the courses to be followed, and of course it's the true course. And then you can of course make remarks on the speed to be conducted, the distance to the next waypoint, and the distance, total distance to go, and other important points as well. So if you make a spreadsheet like this, this should be available for others to see as well, for the other officers to monitor the vessel's passage and progress during the voyage. This video has become a bit longer than what I would have liked it to be, but I had to cover all the essential points of a passage plan. But it's not over, guys. I'll be making a series of videos of at least 5, 6 or maybe more videos. And in my next video, I'll continue talking about passage planning, but in that I will specifically talk about ship routing systems, or vessel traffic service systems and the reporting procedures regarding these systems. All right, so I hope you're liking this series of videos. If you are, I would like to know from your comments and likes below, and if you don't like these videos, also let me know what can I do to improve the videos. Thanks guys, and I'll see you soon. Bye.